Welcome back to React Native Radio Podcast. Episode 301, RNR Explains Native Driver for Animations.
Robin, how often do you turn on the useNativeDriver on the animated module in React Native?
I can't remember a time when I haven't turned on the native driver.
Yeah, it's pretty much always on, right?
But I never knew why I was doing it. That's just what...
Yeah.
All the examples online have it. And
yeah, turn it on.
You always use it.
Exactly. And of course, the animated module is the one that comes with React Native. And, you know, there's Reanimated, which is like a third-party module by Software Mansion that does a great job. And we use it all the time. But, of course, animated is still important because it's still an important part of the React Native ecosystem. Sometimes you don't want to use Reanimated. It's also used by some internal components like Touchable, for example. Touchable opacity will use the animated module to
Touchables, animate. Yeah, because they animate what happens when you press in and press out. There's animations happening there, which you don't think about. But there's a lot of animations and built-in components like that.
Yeah, and the React Native docs have a pretty good animations guide. And animations are important, you know, in a lot of apps. I mean, not every app needs animations, but they I guess there's a quote in our notes. Did you put this?
I did. So this is from the very first paragraph of the animations guide in the React Native docs, which is the best explanation of why you use animations and what they are. And I'm going to read this verbatim because I like it so much. Animations are very important to create a great user experience. Stationary objects must overcome inertia as they start moving. Objects in motion have momentum and rarely come to a stop immediately. Animations allow you to convey physically believable motion in your interface, which is so true. Like, that's why we animate, so that it feels like how real things in the physical world would move.
Okay. It's almost like skeuomorphic. It's like the early days of the iPhone where they were trying to make it feel like real objects in space.
Right, exactly.
Yeah, that makes sense. Like you push a button and there's a little bit of an animation as it goes in.
Right, and it starts slowly and then speeds up and then slows down as it comes to a stop. It wouldn't, like, because real objects wouldn't just like, bam, stop unless they hit a wall.
Yeah. What do you call that? The
momentum and inertia?
Well, it's based on momentum, but there's a word for this. Easing. They call it easing.
Yeah.
Yeah.
Anyway.
So in this RNR Explains, specifically, we're going to be talking about the native driver for the animated API. Of course, remember, RNR Explains is where we drill down into pretty specific aspects of React Native and make sure that we can cover as much as possible in the 30 minutes or so that we have here. And really quickly, I do want to also mention that this episode is sponsored by, surprise, Infinite Red. Infinite Red is a premier React Native development agency located fully remote in the US and Canada. Mostly the US, if we're being honest. If you're looking for React Native expertise for your next project, hit us up. You'll talk with me on Zoom. You'll probably talk with Gant, my business partner, and Derek, who is also involved in our sales process. So definitely reach out, infinite.red/React Native, and don't forget to mention at that time that you heard about us through the React Native Radio podcast. We appreciate that. In the docs, it talks about how the animated API was designed with a very important constraint in mind. It's serializable. That means that you can send everything about that about that animation through from the JavaScript side to the native side before it's even started. And that would allow the native code to like take over and say, okay, this is what you want me to do. I'll do it. Don't worry. Like, you don't have to manage me. I'm good. I will basically do the animation on the UI thread without having to go through the bridge on every frame. And even if you were like bridgeless mode, you know, that could still be a little bit of overhead. So that's essentially, this was designed from the beginning with this sort of thing in mind.
Right. I mean, that's React Native right there, is like doing stuff in JS and then serializing it over the bridge to native.
and then having native do sort of like the end
do
result,
its native thing to make it. It's a native app that you're seeing, but it's JavaScript that told it what to do.
What to do. Yeah, exactly. That's React Native in a nutshell. So what if you just use animated by default, what is it using?
By default, it's using JS. It's in JS. It's using.
So it's not doing that.
It's
not sending it over to the native.
Right. It's not sending it over to native, which is not great for performance because JavaScript is slower than native, and you're using the thread that you're also trying to render your app with.
Yeah, and it's essentially doing this like request animation frame, which is supposed to run 60 times a second or so, whenever, whatever your frame rate is. And then you would do the calculation of like, where should this element be, or what property should it be? And then it's sending it over and saying, hey, do this thing, which uses set native props under the hood. So it's doing it as quickly as it can, but like there's still some lag. You're reliant on the JavaScript thread to keep running at 60 frames a second, and it can kind of like get hiccupy and glitchy. You'll notice this if you try to use just the JavaScript driver. You'll notice these things popping up, especially in older, slower phones.
Definitely. So why is that even the default? That's what my first question was.
Yeah.
Is if this is like not a great experience, why is it the default?
Yeah, I had that question as well. And when we looked into it earlier, there are some caveats with the native driver. So the native driver, of course, just to talk about that, is where the native side is executing the animation. So instead of with JavaScript, instead of having that like run every animation frame, it just sends over, I need this all to happen, including with this timing, this animation, this easing, all of those things. It just does it. And it will hook back with events. We'll talk a little bit more about events as we get into this. But the caveats are you can't animate layout properties like flexbox and position. It doesn't work with pan responder. It does work with like scroll views and on scroll and stuff, but it doesn't work with pan responder. When you're using animated.event, it will only work with direct events and not bubbling events. That's why pan responder doesn't work. It requires bubbling events.
Hold up for a second. What are bubbling events? Because that just sounds funny.
I'm tempted to make some sort of joke about my kids' birthday parties or something, but I don't know. I can't really pull it off here.
Any toddler birthday party is a bubbling event.
It is. Yeah. So we're used to this in web, but if an event happens, like a click event, let's say, on a child component or DOM element, then that click will actually be sent up the hierarchy to its parents. It'll bubble up the hierarchy. You can actually stop it from continuing to bubble up, but it will continue to bubble up if you don't. And so parent events can subscribe to click events that happen to their children. It doesn't, it lets it bubble up. If events do not bubble, then it will only happen on whatever was, clicked on or tapped on or whatever. So that's what a bubbling event is. And animated event does not do that, just direct events.
Right. Okay.
So that's a little bit of a limitation as well. It also, when an animation is running, it can also prevent like virtualized list components from rendering more rows and things like that. So there's a way to get around it by turning off interactions in your animations configuration so that, like you can run that animation while the user is scrolling through a list or something like that. So there are some downsides to using the native driver. Of course, a lot of these things are better with reanimated, but that's outside the scope of what we're going to be talking about here.
Right.
But the vast majority of the time, you're going to want the native driver to be turned on. So it's not on by default, but it pretty much should be.
It's false by default only for like specific compatibility things, and because there are caveats that they want people to turn it on with the knowledge that they're turning it on.
Yeah, that's right. And it's definitely more compatible, has more capability on the JavaScript side, but the performance hit is enough that it just doesn't feel worth it to me. So let's talk about how it works. How does the useNativeDriver? We've talked a little bit about it already, but let's dive into that a little bit. what is happening when you turn on useNativeDriver?
Well, really what happens is that it sends everything about the animation to the native side, and then it runs on the native side. It's not running in JavaScript. It sometimes will pass events back to JavaScript, but it isn't reliant on the JavaScript thread to keep going. It's all running in Kotlin or Objective-C native code.
And it's running on the UI thread. And this is important. I think people need to know this. This is more of an iOS thing, but it also applies to Android as well. There is one, so it's these apps are multi-threaded. There's one thread that is designated as the main thread. And it is like, sometimes you'll hear it called the main queue. And it's the main thread. It's the UI thread. It's where all of the like actual rendering is happening. All the drawing is happening.
And so anytime you use that thread for something else, you're going to get stutters in your UI. The user is going to see that there's like gaps or flashes.
Exactly. And that's why in React Native, the JavaScript thread is a separate thread. We don't run all of the JavaScript on the UI thread. However, whenever you have like stuff going back and forth between those two threads, there's a little bit of an overhead there. And you also can't do any UI stuff on non-UI threads. So you can't actually go in there and be like, draw this thing or, move this thing or whatever. You have to do that on the UI thread. So you want to keep all of the other work off of it. But if it is UI related, it needs to happen on the UI thread. And that's going to be the fastest. Yeah. And that's totally what an animation is good at. So like it's a UI thing. And so you need to run that on the UI thread. So the Kotlin or Objective-C is going to be running on the main thread. It's going to be executing all of the different steps, over time that it needs to essentially every frame, to move elements or animate properties of elements and things like that over time. So that you see that animation happening, also handling touches and sending those events back to the JavaScript thread and over the bridge, or if you're in bridgeless mode, directly to the JavaScript side so that you can then take those things and do things with them.
It works so much better than trying to do it all in the JS thread. What happens if you want to defer something to like wait till all the animations are done?
Yeah, because this happens sometimes. Like you have an animation that happens and then you want like, hey, I want to know when all animations anywhere in the app are done. Then I have this like long running process that I need to have happen that would be really noticeable to the user if you started it during animations. Like everything would start stuttering. It would be a little more laggy. Maybe the user is in the middle of like moving something with their, with their finger or something and so there is an interaction manager .run after interactions thing that you should probably be using for almost everything that you can kind of delay a bit. So a good example of this would be metrics. Like if you collected a bunch of metrics and you want to send it off to the server, that doesn't need to go away like right away. You can actually wait a little bit, do this run after interactions, and then kick off a ping over to the server. If you're doing some sort of calculations, if you're loading something, caching something, that isn't like immediate, doesn't need to happen immediately, just do this and then it'll wait until everything's done. And then, okay, we have a little bit of time where there's a little bit of a gap here. Like let's send this off.
This can be a good tool to reach for if you're trying to improve your app's startup time, or just performance in general. Like if there's a screen that's taking a long time to load, this is a tool you can reach for.
Yeah, and really, I think it's designed in particular for when the user is noticing the performance stutters because of animations and interactions. So you see stutters and stuff, figure out what would be running at that time that's kind of taking, more time. Maybe even things like, I don't know, like hydrating your state model or something like that. Like, something like that could be a longer running synchronous task or something like that. So definitely, reach for this interaction manager .run after interactions. That's a little bonus RNR explains there. But that's essentially what useNativeDriver does. Of course, Reanimated, does a lot of stuff. And actually Shishtoff from Software Mansion was, I believe the initial person to work on the animated useNativeDriver implementation, and then he took that back to Software Mansion and created Reanimated.
Which runs animations on the native.
It does, yeah. I don't even think they have a JavaScript driver. It's just
that's what it does.
native.
You don't have to specify any option. But unless your animations are pretty simple, you're going to have a better time using Reanimated. Simply just because the API there's a lot of developer experience goodies like hooks, and the API is really easy to use and has a lot more features than the default animated API. So I really enjoyed using Reanimated.
We did talk with Shishtoff in React Native Radio 236. The title is Reanimated 2, but Reanimated 3 actually was coming out pretty soon afterward. And so we talk about Reanimated 3 as well in there. And I think they're working on 4 now. Or is 4 out?
4 isn't. I don't believe 4 is out.
4 is not out yet. Okay. Believe it or not, I think we're actually pretty much done with this. And this is what we're looking to try to do with RNR Explains, is do some deep dives into very specific things. This is a very specific thing. Like we could have done the whole animated API.
Right. That would have turned it from a 20-minute episode to a 2-hour episode.
That's true. Yeah. It would have just kept going and going. So I think we'll leave it at that. If you have something that you want us to dig into, just something you've never, you use all the time, but you don't really know how it works, let us know. rnradio@infinite.red, and we'll be happy to take a look at it and see if it's something we want to do in a future RNR Explains. If you want to nerd out more about this, join our Slack community, community.infinite.red. We have well over 2,000 React Native developers in there, and you can also find me on Twitter @Jamon Holmgren. You can find Robin @Robin_Heinz with an E. And you can find React Native Radio @ReactNativeRDIO. Thanks, everybody. We'll see you all next time.
Bye.
As always, thanks to our production team with editor Todd Worth, our assistant editor, this guy, Jed Bartosky, our director of communications and episode release coordinator, Justin Husky, and our guest coordinator, Derek Greenberg. Our producer and host is Jamon Holmgren, and executive producers and hosts are Robin Hines and Mazen Chami. Thanks to our sponsor, Infinite Red. Check us out at infinite.red/ReactNative. A special thanks to all of you listening today. Make sure to subscribe to React Native Radio wherever you get your podcasts. And leave us a review. We'd love to hear what you think.